just do the little intro to this video. Recording has started. Oh, that's a new confirmation. So people are watching this recording. Got to start the recording like 5 minutes ago, but here's the answers. Pause this. This is the answers to your review. Today is Monday, October the 4th. So we're going over number 5 right now. Sorry for the people watching the recording. I forgot to start it. But continuing on to this problem. Yeah, so when you graph this, the solutions will be where it crosses the x-axis. Remember, solutions are the x-intercept. So if you were to type this into Desmos, it would cross the x-axis at 6/5, which is 1.2. Yeah, so it'll cross the x-axis at x equals 1.2, which is 6/5. And graphing is probably the easiest way to solve this. All right, what's the next problem you'd like to go over? Yeah, confirm it. Yeah, so everyone, I think it's like a new row feature. It says, I think it's just telling you we're being recorded. Just hit confirm. It doesn't do anything other than that. Just let you know. All right, number 12. Let's take a look. Number 12. Is this number 12? I don't. Yeah, that's number 12. All right, so for this one, so state the possible rational zeros for each function, then find all rational zeros. Well, I only did part of this problem. I'm not gonna finish all of it, but remember this is the PQ list. Those are the possible rational zeros. So we're gonna do. Remember, P is your 6, Q is your 3. We list the factors of 6 and 3. And then we write the combinations: 1 over 1, 1 over 3, 2 over 1, 2 over 3, etc. Reduce these fractions and then only write them one time. And then to actually check to see which ones work, we do the synthetic division. And where I have this my PQ, we're just going to go through and put 1 here, -1, +1/3, -1/3, +2, -2, and we're going to do synthetic division. And you want to see which ones will give you remainder 0. So the ones that give you remainder 0 are the actual zeros, right? I didn't show the work. All of you can do this, but this is how you would approach this. Another easy way: generate your list and then just graph it, right? We're expecting to have 3 zeros. It may not have 3 rational, or it may not have 3 rational zeros. It may have some irrational values or some complex answers, but graphing it will allow us to easily see which of these numbers in our PQ list are zeros. So that's how you would want to approach number 12. All right, what's next? Number 13. Find all zeros. So this one is nice. It's partially already factored, right? So what you want to do, remember, when it's in factored form, you want to set the factors equal to 0 and solve. So that's what I did. If we can factor further than what it gives you, by all means. But I just subtracted 8 both sides, and then I square rooted. Don't forget, whenever you square root, plus or minus, and the negative comes out in front as an I, and the square root of 8 is 2 rad 2. So hopefully you can do this by hand, or if you have the FX 115 or FX 300, you type that in, it will reduce it for you. The Casio model that I recommend will give you 2 radical 2 as your answer. You just got to know that this negative comes out as an I. Same thing for this one, and all of us should know that the square root of -1 is I. All right, what's the next one? All right, number 16. So I'm making a list of the ones that you asked, and I'm going to let my 8:30, 9:30, 10:30 class know the ones that we did in this class. So maybe they'll choose different numbers than you. All right, number 16. Really, for this one, just go to Desmos and type this into Desmos, and then see which one it is. Yeah, this is super easy because it's multiple choice. So your midterm is all multiple choice. All you do is type this in correctly and then look at the graph and see which one is correct. And the answer for this one is B. You know, we can also see that the multiplicity, this is a multiplicity of 1, 2, and 1. So 1 plus 2 plus 1 is 4. And it's a positive coefficient. So it's a positive even power. So we know it opens up. So really the only choices based on our observation is A or B. And then we can use the rules like, you know, we know it crosses the x-axis at x equals -2. And so there's -2. This actually bounces. See how it bounces at -2 instead of crossing through? It should bounce at +2, x equals +2, which it does on the correct answer. So you can use your multiplicity rules to figure out opens up, opens down, and if it passes through, if it bounces, or if it passes through, and kind of go from there instead of using Desmos. Really up to you. Yep, no drag and drop. All right, let's go to number 21. So we had a question about says write define undefined for expression. So remember, whenever you like if you add or subtract matrices that don't have the same dimensions, it would be undefined. The same thing if you were to multiply matrices that didn't have the same inner dimensions. So if we couldn't multiply these, we would just put undefined. That's what it means. All right, what's our next one? 26? All right, 26. This one says solve the system by transforming a matrix representing the system into reduced row echelon form. So this one wants us to solve this equation or this system of equations by using RREF. Now, it's multiple choice. So even though it says use RREF, you don't, you know, there's really no way for me to enforce it on this problem. You know, we could graph this to see where they intersect. We could use substitution, we could use elimination, we could use the inverse matrix method, we could use Kramer's rule, or we could use RREF, which is what I did here. Or I could even guess and check, right? I could just plug x and y into both equations to see which combination actually works for both equations, right? So I would, you know, check these. I would get false for maybe one or both of the equations, and then I would check B, and I would get true and true for both equations. So there's a few ways to approach multiple choice tests, which is nice. But here's the work for reduced row echelon form. I did row 2 plus 3 times row 1. I noticed that if I did 3 times 2 is 6, and I do -5 plus 6, I get 1. So I was creative. You know, some of you might just divide everything by 2, but then you would have fractions. You know, when I do these, I really try my best to avoid fractions, and I was able to achieve that doing this operation here. Row 2 plus 3 times row 1. That's how I got these values. Then I did 5 times my row 1 plus row 2 to get this second row. And then to make this a 1, I just multiplied, or same thing as dividing, by negative 1 over 51, or same thing as dividing it by negative 51 to get that second row. And then I multiplied my row 2 by 10, add it to row 1. So 0 times 10 is 0, plus 1 is still 1. 10 times 1 is 10, and then 10 plus negative 10 is 0. 10 times negative 2 is negative 20. Negative 20 plus 24 is positive 4. So that's using RREF, which I really like. And I get it why a lot of you may not like RREF. You haven't done quite as many examples that I have in my math career. So these seem a lot harder to you than they probably do to me. And that's okay. We have other methods to solve equations. So if you're not necessarily good at RREF, well, hopefully you're good at another method. It's okay to use fractions. You know, like on unit 2 TGA part 2, which there's a lot of you, there's 22 of you that submitted their part 2. I haven't graded yet, but I noticed some of you approached number 1 and you got fractions, but in the end you didn't, and you got the right answer. You know, it's not the way that I would have done it. You know, like my answer key, I avoided fractions like I did in this problem, but it's not wrong. You just, you know, deal with fractions. All right, so that was number 26. All right, what's next? Number 28. Let's see, 28. All right, this one was quite easy, I think. I feel like you've had these on past quizzes or past practice modules. And again, I really hope all of you spent time going through the practice and learn modules and working out the examples. Again, if you don't like learning from those modules and you really enjoy and it's really helpful watching my live lessons to learn it, that's fine. You need to work out the examples they give you. You know, don't read their explanation, just work out the examples and see if your answer matches their example, because their reasoning may be a different way to approach it than I do, and I like the way I do it best, right? But for this one, matrix equals 2x. So what I want to do is I want to divide both sides by 2 more or less. So I want to factor out a 2. So then I have 2 times a matrix. Remember, X is a matrix. So 2 times a matrix equals this matrix. So by pulling out a 2, now the scalars match, 2 and 2. So more or less, I just divide both sides by the scalar of 2 to get matrix X equals, well, the answer. All right, what's our next one? Number 19. Okay, so for each function, identify the domain. Remember how we talked about in Unit 1, how your domain is derived from your VAs and your holes. Now, if you still have that, I made you a cheat sheet, and I had it on one of the lessons that hopefully you wrote it down or snipped the page. But to find your VAs, we set the bottom, the denominator, equal to 0, and we solve. So again, your domain is derived from your VAs in your holes. So we're going to set the bottom equal to 0, and then we solve. So solve by factoring. We could have solved this by graphing too. So if I type this into the Desmos, wherever it crosses the x-axis, those are the solutions. But I solve by factoring. If you can GCF, you do that first. So we GCF a 2 out, and then I get this, and then this is factored using what I call the simple method, two numbers that add up to the middle coefficient and multiply to the constant. So -2 plus 3 is +1, and -2 times 3 is -6. So that's how I factored this. And then we set the factors equal to 0, and then we get 2 and -3. So those are the values that we have either a VA, a vertical asymptote, or it's a hole. I didn't factor the top. We don't really care about that because remember, domain is derived from VAs and holes. Your domain is everything except those numbers, except 2 and -3. That's why it's all real numbers except for -3 and 2. And they didn't put it in interval notation. I went ahead and I just went from here to the interval notation just to show, just in case if you got a problem on your midterm that instead of showing it in this form, they wrote it in interval form. But what I have written here and what they have written for C, they mean the exact same thing. It just, this is interval notation and this is not. That was number 19. All right, what's next? So there is 30 questions on your midterm. If you can do this review, you're going to ace the midterm. There's no surprises. If you can do this, you can do my midterm. The midterm I made to be rather easy. I expect most of you to get A's on this. But do not take this midterm unless you have actually gone through every problem on the review. I can promise you it's worth it. All right, number 7. All right, number 7. This is number 7, right? Yeah, number 7. It was a long one. Hopefully I sound better. I had my mic on the wrong setting. All right, so this one, solve each equation. Remember to check for extraneous solutions. So here is the question. If I was given this problem on your, if I was a student and I saw this, I'm like, would I really want to do all this work to try to solve this? Probably not. Given multiple choice, I personally probably would either use Desmos to type this in to see where it crosses the x-axis, or I would have just guessed and checked. Looking at this problem, I wouldn't go check A, then check B, then check C, then check D. I would look at my choice and say, hey, 0 is super easy to check. I'm going to check C first. So I would plug 0 into my p-value and to see if I get a true statement, which you will. The answer is 0. So if 0 is correct, the other answer that has 0 is B. So 0 is correct. I would also need to check B for -4. So I would plug in -4 into P, and I would check to see if the left side equals the right side. Well, when you plug in -4 into the equation here, you're going to get a false statement. And do I show that here? No, I don't actually show that here because that's not even one of the possible valid choices. But guess and check 0 works. 0 works. I would have to check -4. -4 definitely does not work. So the answer would have to be on C, just for the only reason we just guessed and check. But here's the work. I'm not going to really go through this. You can look through my work to see how I did it. But when I get down to my answers, I get P equals 0 and P equals 1/2. And this is not even like one half is not even a choice. So I don't include so on your midterm, you will get extraneous solutions for some of these problems, but I don't include the extraneous solution in our solution set. So I don't put x equals, or in this case, p equals 0 and p is not equal to 1/2. Don't I don't put the extraneous solution in there. So even though we get a half as one of the possibilities, it's not a choice. So don't think because we get 0 and 1/2 that you did it wrong. Well, 1/2 actually doesn't work. So we get 1 equals 3 when we plug it in. So yeah, that's the extraneous solution, which is not part of the solution set. When we plug in 0, we get a true statement. So 0 is a correct answer. So that is the only answer. Hopefully that answers this one. Yeah, this is a long problem if you do it this way. I personally would probably just type it in Desmos and see where it crosses the x-axis, which it crosses at x equals 0. All right, that was number 7. All right, what's next? Number 11. Okay. Some of you are like frantically probably you have the PDF I sent to you open. You're kind of clicking through to see which ones you want me to try to explain, right? That's okay. That's okay. All right. So number 11, find the remainder when f of x is divided by x minus k. We've done these in unit 1 maybe. It's been a while, right? So here's the function, and your k value is 2. So we're going to use remember the remainder theorem. We use the two ways to do it. We can either plug it in, or we can use synthetic division. So I show it both ways. I set it up. K is 2. So I just do synthetic division, and then we get remainder 9. So that's the answer. Also, remember two ways to do it. Remember the remainder theorem. We could actually just plug into the actual function. When you plug in this case, we get 2 for x. The answer you get, so when you evaluate this function for 2, the answer you get is the remainder. So that was the remainder theorem we talked about in unit 1. So I do show that by plugging in 2 and then doing the math, and I get 9. So it's two ways to confirm that we get 9 as the remainder. That's number 11. Okay, what's next? Okay, so I just read your email. The I sent the review out in an email on Friday. Like it was Friday afternoon, maybe it might have been Friday morning. One of the two, morning, afternoon. But guys, I always put in the subject of my emails MTH 403A. That way you always know it's for math and not some spam. So I do label my emails accordingly, so it's easy for you to identify which ones are from me. So MTH 403, please read my emails. I usually don't write very long emails. I don't like reading long emails. I don't like sending long emails. But if you get one from me, please just scan through it. I usually try to bold or underline like really important parts, like it's like unit 1 is locking or unit 2 is locking, or here's the review. Please do it, right? All right, number 2. Let's take a look. All right. So this one we want find the answer to this inequality. I think this was probably, I want to say this was the first or second lesson of the school year. Maybe. All right. So we solve this, move the 6 to the other side, and then we factor this, set the factors equal to 0, which we get, x equals -8, -8. So this one, because it's a greater than or less than symbol, it's going to be a hollow point at -8. Let's say I got two different numbers. Let's say I got -8 and like -5. I would have a hollow point at those two values, but because they're the same, it's just one single hollow point. And then we need to check to the right and to the left. So I chose negative, I could have chosen like -9. I chose -10 because, well, 10 is easy to plug in. So I plug in -10 and I get a true statement. So that's why from my hollow point, our graph goes left forever because it's true. Then we have to check to the right. So I could have checked -7, -6, -5, -4. I plugged in 0 because 0 is also an easy number to evaluate. So I plugged in 0, and I also got a true statement. 70 is greater than 6. So, that's true. So that means my arrow goes to the right forever from that hollow point. So the answer is all real numbers except for -8. And that's what this shows in interval notation. So from -infinity to -8, then from -8 to infinity. That was number 2. Okay, what's next? Number 10. All right, number 10. All right, we got the dividend divided by our divisor, x plus 5. This is synthetic division. We could use long division, but we don't have to because it's in this form. So I set it up. Remember, when you go from this form to synthetic, and we take the factor and you take the opposite of this number, so that 5 becomes -5 over here. And then vice versa, going from the equation, the -5 to factored form becomes x plus 5. Yeah, so we do synthetic division. I think all of you can do this, right? We drop the 1, -5 times 1 is -5. This plus this is -1. -1 times -5 is +5. Add these together, you get -4. Times -5 is +20. Add these together, you get +10. That's your remainder. So when doing synthetic, we have to drop the power by 1 so that x cubed becomes x squared. X squared minus 1x minus 4 plus your remainder. And it's your remainder 10 over your divisor, which is x plus 5. So that is number 10. Oh, you meant number 9? Okay, well. Number 9. Long division. Ooh, that's a fun one. All right, so for number 9, we can't do synthetic division. But when you set this up, don't forget your placeholders. This goes 4, 3. We're missing the 2, 1, and then constant. So we have to have a placeholder here. Also over here, you don't need a placeholder in your divisor. I went ahead and put it in just so I wouldn't, make mistakes on my columns. You don't have to have a placeholder here. I put it there Just keeps everything organized without thinking about it. So, we look at 4x squared and 24x to the fourth. What times this number or this term will give me this? Well, 6 times 4 is 24. So there's my 6. And then, what times x squared will give me x to the fourth? Well, I need 2 more x's. So that's why I have x squared. So 6x squared times 4x squared is 24x squared. 6x squared times 0 is just 0. And then 6x squared times 4 is 24x squared. And then don't forget to change your signs. So I didn't put that in there. So I wanted to kind of show this. So once you do that, we change the signs. And then these cancel out. 16 minus 0 is still 16. 0 minus 24 is negative 24. Also, if you notice, see how I have my x to the fourth column, x cubed column, x squared column, x column, and then my constant column. That's important to keep everything lined up. But, once you get to this step, we look at this. What times this term will give me this term? So 4 times 4 is 16. That's why it's a 4 there. And then x squared times x will give me my x cubed. So that's why this is 4x right there. So we do 4x times this is 16x cubed. 4x times 0 is just 0. And then 4x times 4 is 16x. And then don't forget, we have to change our signs. And then these cancel out. Negative 24 minus 0 is still negative 24. 23 minus 16 is 7. And then this negative 23 just carries down. And now the problem kind of starts over. So we look at this term, what times 4x squared will give me negative 24x squared? Well, negative 6 times 4 is negative 24. And that's why we have negative 6 here. And then x squared and x squared, I don't need any more. So that's why we don't have any x's. But it's kind of a giveaway. See, if you keep everything lined up, we should expect it to go x squared, x, and then just the constant. We multiply negative 6 times all 3 of these to get these 3 terms. Oops, sorry, these 3 terms here. And then we have to change the signs. So this becomes a positive, that becomes a positive, that becomes a positive. Then we are going to combine. So this plus this is 0. 7 plus 0 is still 7. Negative 23 plus 24 is positive 1. And, we're out of columns. So that is your remainder, this entire piece. Because nothing times 4x squared is going to give us 7x. We already have too many x's already. That's the problem. So this is your remainder. So we're going to write 6x squared plus 4x minus 6 plus your remainder all over your divisor. And our divisor was 4x squared plus 4. Looking at these choices, as you go through this problem, we have 6x squared here. Well, A, B, and C, and D, they all have 6x squared. So that doesn't help us. Our next term, 4x, 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 4. So they all have 4x also. Yeah, so that doesn't help us either. Our next term, negative 6. So we got negative 6, negative 6, negative 6. Yeah, so look, the answers are all the same until your remainder. So, choosing the correct answer really comes down to, our remainder, and if we got the remainder correct. So 7x plus 1, which is, B, right? Yeah, that's probably, I think out of all of these, is probably the longest, or, well, I don't know, the hardest maybe for some people, a lot of people. All right, what's next? Nope, midterm is just purely a multiple choice test. No TGA. Aren't you happy? Send you the PowerPoint. Um, tell you what, people that are here, I'll link it right now. How about that? Yeah. So there's the file, the PowerPoint. Actually here. All right. Any more want me to go over before we call? We still have another like 13 minutes left. What else? What else? What else? 27. I don't remember. Maybe. Hmm. I think we did number 26. 27 is on the same way. It's just RREF. So again, we could have just graphed this in Desmos to see where they intersect. We could have done substitution method, elimination, inverse matrix method, Kramer's rule. Yeah. But we set this up and we want the top left to be a 1. And I see right away that 2, 4, and 10, these are all even. So I can multiply row 1 by -1/2, and that will make this a 1 and keep everything in integer form instead of fraction form. Multiply row 1 by -3, add to row 2. So that's how we get here. And that's nice. So when we do that, it not only makes this a 0 like we wanted, but it also made that a 1, which we wanted to do next. So that saves us a step. So now we're going to use this 1 to make that a 0. So we're going to multiply row 2 by 2 and then add it to row 1. And that's how we get this. And yeah, so in 3 operations, we were done with this problem. X is -3 and Y is 1. And we could have just guessed and checked. We could just plugged all these in to see which one actually works. All right. Any others before I show you the password? No, then I guess we'll just call it, right? Rest you're probably good on. I linked you the actual PowerPoint to kind of click through. So let's go ahead and just jump right to the password of this midterm. All right, password for this midterm is pi 314159. Take note, the I is lowercase. The I is lowercase. So make sure that you finish reviewing for your midterm today and take your midterm today. We are starting Unit 3 tomorrow. Also, I think Raise My Grade is coming up. Let me see what it says on our calendar. It might be next week, but it might be this week. Let me take a look. Raise My Grade, October 11th to the 13th. Yeah, so it's actually next week. Raise My Grade is next week. You are allowed to retake Unit 1, Part 1, Unit 2, Part 1, or even your midterm. But really, the midterm is pretty easy, so I don't expect anybody to retake your midterm. So yeah, if you didn't do great on your Part 1 or Part 2, or even missed Part 1 or Part 2, this is an opportunity next week to retake the test of one of those units. Make sure you read the directions completely and fully. They're very specific. There's no need to email me. How do we do this? The instructions are long, but they're very precise. And there's a deadline next week on it. So that starts on Monday next week, the 11th. All right, everyone. Well, good luck, and I will see you all tomorrow for Unit 3, Lesson 1. How much will midterm affect our grades? Oh, well, that's all depends. I don't know how much it's worth. You're going to have to add up. So remember, this is all points, right? It's not like weighted. So you got to see how many points you have now and how many points the midterm is worth, and then kind of do your own math. All right, everyone. Good luck. See you tomorrow.